Hello, welcome to the Fiberglass Reinforced Plastics Institute YouTube channel. Thank you for tuning in with us for What is FRPI 8310 Inspector Qualification about? The 60-second answer to this question is that the FRPI 8310 Inspector Qualification is a comprehensive practice for periodic documented fiberglass reinforced plastic, or FRP, tank inspection. It was launched in October 2018 in response to industry needs centered around addressing laws and supporting an effective facility asset management program. This practice has undergone long-term development that drew on a balanced group of industry experts before launch and is administered by a nationally recognized and generally accepted industry organization. It involves a well-documented, simple 5-step inspector qualification process. The process includes delivery of education by a competent first-party source, inspection procedures incorporating good engineering practices, and a means for recognizing a responsible level of FRP tank inspector expertise. There is a bit more to it than this, though. Our informative, revealing story follows. Response to industry needs. Let's take a look at the industry needs emerging since 1990 that this inspector qualification program has been introduced to satisfy. These situations include evolving inspection laws, standard-setting precedents, FRP practice initiatives, special interest groups rallying, plus challenges and opportunities. Evolving inspection laws. Since 1990, the Environmental Protection Agency, EPA, the Occupational Safety and Health Administration, OSHA, and several states throughout the United States have been busy over the past few decades developing laws in response to disasters affecting our health, safety, and the environment. Here are some highlights of what has been going on. In 1988, the Ashland Oil Company in Floreve, Pennsylvania had a tank split apart and collapse, spilling 4 million gallons of diesel oil. The oil overfilled the tank containment dike, flooded the parking lot, drained into a storm sewer, and then flowed into a nearby river that carried the spill downstream for 33 miles. In the 1990s, the EPA formed the Spill Prevention, Control, and Countermeasure, or SPCC, Task Force in response to the spill. This effort led to the regulation now known as 40 CFR Part 112, Oil Pollution Prevention. This Oil Pollution Act amended the Clean Water Act with final revision in 1994, requiring facility-specific discharge response plans. Amendments to this regulation were finalized in 2002, and the SPCC guidance document was republished in 2013, where Chapter 7 covers inspection, evaluation, and testing. Chapter 7, Figure 7-4 of this guidance document, summarizes integrity testing and inspection program documentation required for bulk storage containers at onshore facilities. 3 facility plan classes are provided for a professional engineer certified plan facility, Tier 2 qualified plan facility, and a Tier 1 qualified plan facility. All plans are required to be provided in accordance with an industry standard that applies to the containers. A written inspection and test plan on facility class is required to be implemented at these facilities. Each plan is to be certified by a licensed professional engineer or owner-operator, providing accountability via a qualified individual. In 1989, the Phillips 66 chemical plant in Houston, Texas, had a large explosion and fire. The initial blast registered 3.5 on the Richter scale. It took 10 hours to bring this extensive fire under control, killed 23 employees, and injured 314. The facility was devastated, and Phillips paid $4 million in fines. In 1992, OSHA formed the Process Safety Management, or PSM practice, in response to the explosion and fire. This led to the regulation known now as 29 CFR 1910-119. This regulation emphasizes the management of hazards, plus establishes a requirement for comprehensive programs integrating management practices, technologies, and procedures. Program coverage provides for a practice that pertains to facilities that manufacture, handle, store, and use listed highly hazardous chemicals. Process equipment covered in these facilities are pressure vessels, storage tanks, process piping, ventilation systems, pressure relief, vent systems, related devices, pumps, plus controls such as monitors, sensors, alarms, and interlocks. There are 14 program elements that include employee participation, process safety information, process hazard analysis, operating procedures, training, contractors, pre-startup safety review, mechanical integrity, hot work permits, management of change, incident investigation, emergency planning and response, compliance audits, plus trade secrets. The OSHA PSM Mechanical Integrity Program element rules require periodic documented inspections performed by inspectors officially trained and qualified by a competent first-party source, training and qualification conducted under well-documented practice, following written procedures incorporating good engineering practices, plus element rules administered by a recognized and generally accepted industry organization. In 1999, the EPA Risk Management Program, or RMP rule, initial compliance deadline arrived. This brought about the regulation known now as 40 CFR 68. This regulation parallels the OSHA PSM practice. Several state regulations have also evolved from this RMP and other PSM rules. General guidance provided under the RMP rules covers maintenance and mechanical integrity requirements, where these areas are characterized by written procedures, training, plus inspection and testing activities. Examples of state agency laws following on to the EPA and OSHA mandates include the State of Massachusetts Fire Marshal's Office Program 502 CMR 5.00, New York State Department Environmental Conservation Title VI, Chapter 5, Subchapter E, Part 598, New Jersey Department of Environmental Protection Title VII, Chapter 1E, plus Pennsylvania Department of Environmental Protection Title 25, Chapter 245. These laws require daily, annual, and 5-year inspection intervals for tanks ranging in capacity from 185 to over 10,000 gallons. Some states echo federal mandates for the scope of inspector qualifications. As an example, New York DEC Part 598.7, Paragraph C, governing 5-year above-ground tank system inspection intervals, goes on to state that the inspection must be consistent with a consensus code, standard, or practice, and be developed by a nationally recognized association or independent testing laboratory. Standards setting precedents. In response to both federal and state laws evolving since the 1990s, tank owners have been required by law to prevent, prepare for, and respond to oil and chemical-related disasters. To accomplish this, these laws essentially say that regulated tanks shall be inspected by an officially trained, experienced, exam-qualified, and well-documented individual utilizing a written inspection and test plan procedure on a prescribed schedule following a good engineering practice, where each of these virtues are enabled through a standard practice facilitated by a nationally recognized and generally accepted industry organization. Consequently, industry organizations needed to publish and support standard practices that produce reasonably educated and well-qualified inspectors in order to meet these laws. The American Petroleum Institute, API, was at the forefront of inspection standards development beginning in 1991, and was then followed by the Steel Tank Institute, STI, with their first inspection standard in 2000. Results in qualifying individual inspectors accelerated for steel tanks in the petroleum industry and beyond, with over an estimated 5,000 inspectors qualified now in the United States alone. These steel tank inspection standards have long preceded and therefore established a precedence for standardization for qualifying inspectors serving the fiberglass tank industry. API responded to the EPA and OSHA laws with 3 comprehensive standard and recommended practices. API 653, Tank Inspection, Repair, Alteration, and Reconstruction, introduced in 1991. API 580, Risk-Based Inspection, introduced in May 2002, plus API 571, Damage Mechanisms Affecting Fixed Equipment in the Refining Industry, introduced December of 2003. These practices include a scope that speaks to the many requirements mandated by law. Topics addressed to varying degrees provided for a written practice, body of knowledge, materials evaluation, damage mechanisms, integrity and leak testing, inspection procedures, checklists, operability assessment, reports and record keeping, supporting education, an application process, minimum qualifications and exam, award, renewal, and denial of credentials, termination and suspension, appeals process, certification and licensing, plus liability protection of various forms. STI responded to the laws with one standard, STI SP001, Standard for the Inspection of Above-Ground Storage Tanks, introduced in September 2000. It too is regarded by many as a comprehensive standard, similar to, but also expanding some on API inspection standards. FRP practice initiatives. While FRP has earned great respect in a position as the material of choice for numerous chemical storage applications, it has been regarded by many as a mystery material, with very limited standards governing the education and qualification of FRP tank inspectors. Given FRP's many layers of alternative reinforcements saturated with various thermoset resin and cure system options, a wide variety of composite materials have been laminated for tank components that are characterized by both isotropic and anisotropic properties. This complexity, coupled with laminating quality issues, has been problematic to a degree, resulting in a large tank price spread in the market and a remarkable variation of tank material performance for decades. Design variability, while an advantage of FRP, has also inhibited development of inspection standards. Consequently, the FRP industry has historically made limited progress with developing full-fledged, robust, sustainable tank inspector education and qualification practices in response to the EPA, OSHA, and state regulations at law. Niche industry organizations with well-intended professionals supporting the pulp and paper, petroleum, and chemical processing industries had made a noteworthy effort with an initial response to these rules at law from 1999 through 2012. However, general guidance documents published had shallow technical scope, plus varying content errors and conflicts. Additionally, they have not evolved into a sustainable industry standard supported by written administration requirements, third-party vetting, certification mark recognition, plus full-time industry organization staffing to manage and deliver a practice beyond the volunteers that help develop it. TAPI, the Technical Association of the Pulp and Paper Industry, published a technical information paper developed by a small group from their non-metal subcommittee in 1999, referred to as TIP 0402-28, Best Practice for Inspecting Used Fiber-Reinforced Plastic Equipment. With only 12 pages of content, it provides very limited general guidance and was not intended to address rules of law governing tank inspection or facilitate a means for education and qualification of tank inspectors, like API and STI standards. The Fiberglass Tank and Pipe Institute, or FTPI, serving primarily the petroleum industry, introduced a publication in December 2007 referred to as FTPI 2007-1, Recommended Practice for In-Service Inspections of Above-Ground Atmospheric Fiberglass Reinforced Plastic Tanks and Vessels. With 38 pages of content, it too had very limited information and did not facilitate a means for sustainable education and qualification of tank inspectors under EPA and OSHA regulations. This practice was developed under the direction of and owned by the FTPI Executive Director, who retired in 2017 following 24 years of service and retained intellectual property rights to the practice. At the time of this Executive Director's retirement, the FTPI decided to no longer support this recommended practice, removed it from circulation, and has disowned association with it. As the FTPI withdrew support for this practice, a third-party for-profit company, under its own initiative with good intentions, had acquired some intellectual property rights from the retired FTPI Executive Director and commercialized tank inspector certification with the now rebranded first edition of the initial December 2007 works. This approach to inspector education and qualification, however, is inconsistent with requirements of federal and state regulations and not sustainable, as this company is not a generally accepted nonprofit industry organization, and the rebranded practice is no longer a consensus standard, given it is a rebranded first edition of the original FTPI December 2007 review document. The original document upon which this rebranded program is founded is also substantially deficient for the intended purpose of educating and qualifying tank inspectors. Additionally, the company does not possess adequate FRP subject matter expertise to be responsible for such an inspector education and qualification program. The repurposed works are remarkably flawed. Plus, this company, the retired executive director, and the FTPI have published a disclaimer for any liability associated with the former in this rebranded program. The Materials Technology Institute, or MTI, serving primarily the chemical processing industry, introduced an inspection training program in 2012 as a means to provide education and certification of general FRP inspectors as opposed to tank inspectors. This included a course handout, 2.5 days of instruction by a few well-respected FRP industry experts who developed course content, and about an hour-long test. This program was made available to anyone volunteering to have sufficient inspection experience, as benchmarked against course recommended prerequisites similar to API 653 education and experience requirements. No published sustainable industry standard practice has been made commercially available addressing EPA, OSHA, and state tank inspection regulations. Special interest groups rallying. A coalition of special interest groups formed under the name Environmental Justice and Health Alliance for Chemical Policy Reform, the EJHA-CPR. A chief concern of theirs is for public health and safety, plus environmental protection as it relates to chemical spill disasters. In 2014, they published a position that evolved into a lawsuit against the EPA in 2015, and the EPA responded under a United States District Court order in 2018. In 2014, the EJHA-CPR published a demographic analysis identifying chemical disaster vulnerability zones in the United States. It was titled, "Who's in Danger?" This analysis was supported by several special interest groups. Over 3,000 communities were identified as living under the threat of toxic chemical disasters, with over 134 million Americans living in danger zones around 3,433 facilities. Of these facilities, the water and wastewater treatment sector accounted for 57% of them. It was reported that the U.S. Coast Guard data shows 18,764 chemical spills between 2005 and 2014, where 1,294 cases of hazardous substances reached bodies of water and 300,000 people's drinking water was poisoned by the Elk River, West Virginia spill. The U.S. Chemical Safety Board also screened more than 250 high consequences for chemical incidents per year. These incidents included death, injury, evacuation, and serious environmental or property damage. This demographic analysis points to risks being real, and regulation or stricter enforcement of existing laws is needed. In 2015, the EJHA-CPR sued the EPA. Their lawsuit filed cites Congress mandated the EPA issue regulations as soon as possible in 1972. The EPA did not respond to Congress and ignored issues for over 4 decades. Plus, EPA neglected to prevent and contain discharges. In 2018, the EPA responded to the EJHA-CPR lawsuit by issuing a proposed hazardous substance ruling. This led to the regulation known now as 40 CFR 151, Hazardous Substances Spill Prevention. In preparing their response, the EPA conducted an incident study to justify the need for a new rule. The study reports that 285,867 releases were reported from 2007 to 2016. 9,416 releases impacted water in the EPA jurisdiction. 3,140 releases reached water. 2,491 releases were from non-transportation sources, and 117 releases resulted in evacuations, injuries, hospitalization or fatalities, plus waterway closures or supply contamination. Upon completion of the EPA study, their proposed response to the lawsuit concluded that, based on EPA analysis and an existing framework of regulations, plus overall multiple statutory and regulatory requirements established under different federal authorities, the EPA is not proposing additional regulatory requirements at this time. Highlights of the EPA research show 563, or about 42% of discharge causes, are attributed to equipment failure. 21% of most frequently discharged hazardous substances are typically contained by fiberglass tanks. Plus, mechanical integrity and personnel training are reiterated as critical program elements in existing EPA and OSHA regulations aimed at public and environmental protection. Challenges and opportunities. There are a number of stakeholders with varying needs jockeying for position in the tank inspector arena as laws evolve and standards are established, creating a situation with a few challenges and many opportunities. Stakeholders facing these situations include owner end users, inspection and testing companies, manufacturers, agencies insuring against disasters, plus federal and state regulators. Stakeholder challenges driving needs go even deeper than laws and standards. These added challenges stem from the nature of FRP tanks themselves, as presented earlier, combined with the state of the relatively young FRP industry now after 65 years since inception in the 1950s. Inspecting FRP tanks can be challenging due to the impact composite material complexity has on tank performance, and its resulting unpredictable nature of premature failure. To illustrate this challenge, let's take a look at a couple of asset management concepts. The first concept is the potential failure to failure curve, where we look at equipment mortality curves with asset condition on the y-axis and time to failure on the x-axis. In theory, tanks start out new. Condition begins to deteriorate, then we see signs of potential failure if we look, which is labeled as point P. The tank eventually provides an inadequate level of service, and then it is deemed to have failed, which is labeled as point F. The time from point P to F is called the PF interval for predictive and condition-based maintenance. Here's an example of applying this concept to FRP tanks and sodium hypochlorite service, where the tank on the left went 18 months to failure, the one in the middle 7 years to failure, and on the right 16 years to failure. As you can see, time to failure is not necessarily age-related for FRP tanks. So, this traditional time to failure concept may be a challenge for inadequately educated and qualified inspectors to apply for FRP tanks. The second concept is risk-based inspection, where we have likelihood of failure on the y-axis and consequences of failure on the x. Consequences being financial, health and safety, regulatory non-compliance, plus community perception. The red area is a high level of risk, yellow medium, and green low. An inventory of FRP tanks containing hazardous substances typically has a range of risk exposures that fall within the window shown here. However, due to the unpredictability of FRP tank failure and hazardous applications, this traditional inspection concept may be a challenge for inadequately educated and qualified inspectors to apply, resulting in high-risk situations being missed. Premature FRP tank failure is a noteworthy concern. The estimated cost to industry is high and underscores stakeholder challenges. In estimating the cost of premature failure to U.S. industry, we know that the corrosion sector covering all FRP chemical process equipment accounts for about 22% of the total FRP industry market. This data is based on pounds of resin shipped to manufacturers per ACMA and Lucentel research. This equates to approximately $5.1 billion in corrosion equipment purchased per year. Over the past 30 years, it's projected that $3.86 billion average per year has been purchased, and today we have a $115.8 billion FRP installation base. Given the size of the installed FRP equipment market, it is estimated that premature failure amounts to $357 million per year, or 7% of sales. The above-ground storage tank segment is about 30% of this total, or $107 million in premature failure annually. This is remarkable and places a very high importance factor on the need for well-educated and qualified FRP tank inspectors. The state of the FRP industry has been posing stakeholder challenges for decades. Without a comprehensive inspector education and qualification program, it has been impossible to comply with evolving EPA, OSHA, and state laws. Special interest groups have also been drawing attention to failure incidents and risk we face. Many stakeholders cannot easily and concisely identify or differentiate well-educated and qualified FRP tank inspectors, leaving themselves at risk in a difficult situation trying to determine who is unqualified, good, better, or best. On the flip side of challenges are stakeholder opportunities. A new, comprehensive FRP inspector qualification practice has been needed that builds on the works of others, addresses inspection-related laws, establishes minimum inspector skill levels, and positions recognizably qualified inspectors for minding risk. An enhanced level of education that helps inspectors more accurately predict failure incidences and avoid hardship has also been needed. Other valuable opportunities from a business perspective includes a need for a practice that helps lower asset management costs and improve level of service, advance career building and company expertise, leverage competitive advantage, enable officially recognized industry leadership, plus save and or make more money. Last but not least, a practice is needed to help prevent fewer injuries, fatalities, and environmental damage. Comprehensive practice. Above-ground chemical storage tank owners as a general community have been struggling with effectively managing their aging FRP assets and complying with inspection-related laws, given no comprehensive FRP tank inspector education and qualification standard practice has existed. Consequently, anyone who appears to know something about fiberglass may have been employed to perform tank inspections. The contract tank inspector billing rate range from low to high is about a 2.4 multiplier as a result, where inspector expertise ranges from someone sounding like they know what they're talking about to a senior FRP materials consultant with a thorough background in engineering, manufacturing, installation, repair, and alteration. Many owners may have simply been unaware of these latent risks and exposed themselves for decades. The FRPI 8310 Inspector Education and Qualification Practice, introduced in October 2018, is a thorough response to industry needs presented here, where the practice includes methods to help overcome these challenges and capture opportunities. Here is an overview of this comprehensive practice, program basis, objectives, and general content. The FRPI 8310 Inspector Qualification Program is the first full-fledged practice available that covers FRP above-ground storage tanks. This program is facilitated by a vetted nonprofit industry organization incorporated as the Fiberglass Reinforced Plastics Institute, known as FRPI, with articles of organization first filed in the Commonwealth of Massachusetts in 2003. This standard practice is aimed at hazardous incident prevention, from simple leaks to spills caused by events such as overpressurization disasters, safety and environmental protection, plus business hardship avoidance. This program is supported by a very comprehensive manual with 130 pages of color illustrated works. It includes methods for original materials benchmarking, damage mechanisms analysis, plus integrity and leak testing necessary to make reliable condition assessments and sound suitability for service determinations. The program is intended to address EPA, OSHA, and state regulations at law, meet or exceed tank inspection standards precedent set decades ago by the nearly century-and-a-half-old steel industry, substantially exceed prior FRP practice attempts, deliver against FRP industry opportunities, plus support sustainable education, certification, and licensing of FRP tank inspectors. Long-term development. A tremendous amount of industry effort and funding has gone into the development of this FRPI 8310 Inspector Certification and Licensing Program. Third-party accreditation of the program is in process, and the cost to become certified and sustain certification has been strategically determined. This inspector qualification practice has been in the making for over 30 years and involved more than 1,200 hours of development work in the 2 years prior to launch. The published works supporting the program are a compiled practice that engaged a balanced mix of industry experts in business categories including FRP consultants, testing companies, manufacturers, owners, government, API and STI inspectors, raw material suppliers, plus licensed professional engineers. The effort, materials, and facilities required to launch this program have been funded through the Fiberglass Reinforced Plastic Institute mission work, comprised of manufacturer and equipment certification, seminars, services, and membership. The Registered Continuing Education Program, or RCEP, is a nationwide organization that has vetted and been recognizing FRPI since 2011 as a continuing education provider for licensed professional engineers practicing in the FRP field. The FRP 831 course supporting FRPI 8310 inspector credentialing provides 32 hours of professional development credit under this RCEP program. FRPI has been recognized by the United States Patent and Trademark Office, or USPTO, since 2014 as a certification mark owner and certifying body for FRP equipment manufacturing, including tanks, plus odor and air pollution control equipment. These marks awarded to FRPI are founded on comprehensive certification programs written by FRPI that underwent substantial vetting by USPTO attorneys prior to award. The standard practice upon which the FRPI 8310 Inspector Certification Program has been founded is modeled after these successful certification programs. As this FRPI Inspector Program gains momentum in commerce, a USPTO mark will be sought after for the standard practice 8310 too. It is important to note that FRPI registered certification marks applied on goods or services is substantially different than a trademark. A trademark is simply any word, name, symbol, or design, or any combination thereof used in commerce to identify and distinguish goods or services of one supplier from those of another and to indicate source. Whereas a certification mark owned by an organization such as FRPI is used in commerce by a company other than the mark's owner to symbolize the mark owner completed its auditing, inspection, and testing related to the marked goods or services. This certification mark also indicates legal assurance that the supplier of goods or services is rightfully listed, regularly audited, and that its goods and services are identical to that represented. A certification mark owner is generally a trade association like Factory Mutual or Underwriters Laboratory, who in their instances certify fire retardant and smoke development characteristics of FRP material. FRPI is currently working towards achieving American National Standards Institute, or ANSI, accreditation for this FRPI 8310 Inspector Certification Program under the ANSI ISO IEC 17024 International Standard. This ANSI program pertains to conformity assessment associated with general requirements for bodies operating certification of persons. A call for industry comment on this FRPI 8310 Inspector Certification Program has been publicly made since October 2018 and is echoed here. Industry and the general public are invited to contact FRPI and comment on the FRP Tank Inspector Certification process and inspection practices governed by SP 8310. All comments will be taken into consideration for future development and publication of this practice as a consensus standard. This inspector qualification program has been made available at a discounted market rate cost below other comparable industry programs, supports related operations at FRPI, and provides sustainability for the program over decades to come. 5-step inspector qualification. It is easy and fairly quick for experienced FRP tank inspectors to become a certified and licensed FRPI 8310 inspector. Simply purchase and read the above-ground storage tank inspector certification and licensing manual detailing requirements. Go through a credentialing process to demonstrate minimum required personal and employment qualifications, participate in optional courses, pass a written exam, and then receive the inspector certification award. A thorough overview of each step, plus the color-illustrated manual with over 100 laminate, visual imperfection, and damage mechanism photos, is provided on a YouTube feature titled How to Become an FRPI 8310 Inspector. Learn more. Please be sure to watch these other YouTube features titled How to Become an FRPI 8310 Inspector and Why Employ FRPI 8310 Inspectors. There you have it. That's what FRPI 8310 Inspector Qualification is about. Thank you again for your interest in tuning in with us. We hope to see our program working for you and your operations soon.